Guys, today we are going to explain a problem posted by Dash. Alright, so let's begin. Um, its rating is 1200. Alright, so as always, we are going to introduce this problem by explaining the examples here. So the first number of the input is 6. So we have 6 test cases here, right? So for each test cases, it has several number of characters. So the character here means the moving direction of the robot. So a robot starts at the uh, starts from the original position, which is 0, 0, right? And L means it goes left. Right means it goes to right. Up means go up. And D means go down, right? So, so the string here says the directions that the robot can move, right? So this means it goes down, goes up, goes right, goes left, right? Like this. And the question is to remove some of the movements and so that you can make sure that the robot will travel some distance and come back at the original point. And you need to make sure that um, except for the original point, you only travel all of other positions only once, right? So if you travel like this, you visit this position twice. So this path is not valid. So you need to remove some of the movements and make sure of you um, come back to the original position and never travel one position twice. And you can um, rearrange all of the movements in the way you want. And you need to make sure that you remove minimum number of movements, right? So, for example, for the first test case, its original movements are left, right, up, right? So in the end, it comes to this place. So in order for the robot to come back to the original place, we need to remove this guy, right? So we remove up, and then we got left and right, and the maximum uh, distance the robot can travel is 2, right? Just go left and right. And for the second test case, actually it's too long. Let's do a simpler one for this one, right? Is go up, right, down, up again, and right, right? So there is no L in this sequence, right? So the robot can never come back. So the answer is go up and down, right? So we just have two movements in the result. Just go up and down. You cannot go right because there is no left in this sequence, right? So how do we solve this problem? So let's say we have some we already know the answer of the sequence. Let's say we already know the sequence is left, right, left, right, up, and down. So how do we arrange them in a way that we don't have to visit one place twice? So we can always arrange it in this way, right? So put the down first, right? And then put the right characters. And then put the up characters, right? We only have one up and down here, so we put one characters for each. And we put a L in the end, right? So what sequence do we got here? Is D R R U L L, right? So we can rearrange the characters in this way that we can always come back to the original position, and we never travel one place twice, right? We only need to make sure that we have the same number of R and L, and also the same number of D and U, right? So um, let's look at the steps we can solve this problem. So the first step is count how many left, right, up and down in our input, right? And then we find out the minimum number of L, right? L and R, right? So in this way, we can know how far we can go horizontally, right? Horizontally, right? And we can get the minimum number of up and down. So we can know how far away we can travel vertically, right? And uh, this guy is the number of L and R's in our result. And this is the number of U and D's in our result, right? And you need to um, catch a edge case. That is, if one of the number is zero, for example, L, we have zero L's. In this case, we can only have one, at most one U in our result, right? Because let's say we have two U's and two D in our input. Can we go up twice and go down twice? No, we can't, because in this way we travel the second position twice, right? So we can only go up once and go down once, right? So that's the edge case here. So after we get these two numbers, we can output the answer, right? So we output this number of L and output this number of U, then output this number of R, then output this number of D, right? So we get a route like this: left first, up second, right third, D last, right? You can arrange it any way you want. You can arrange it like this, like this, like this, right? Any way you want. It's not so important, right? So I guess that's all. Let's look at the code here. So this map, we keep a record of all the numbers of characters, right? So we count the characters here, and we get the horizon distance here and the vertical distance here, right? So it's both the minimal value of something, right? And then we tackle down the edge case. So make sure we handle the edge cases that v equals to 0 and h equals to 0, right? Then we output the distance, right? And then we output the number of L's, U's, R's, D's um, in this way, right? Then we are done. Cool. I guess that's it for today. Hope that helps. Thank you for watching. Bye bye.